Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions for Codeforces round 826, which was rated for Division 2. So we are going to discuss the first 5 questions, and this video can be a bit lengthy. So we'll just include the chapters at the video description. You can just skip to whatever question you want. So let us quickly start with the first question. So the first question says that we have been given two t-shirts and they are basically the t-shirt sizes A and B. Now the t-shirt size can either be equal to M or they can be a string consisting of 0 or more X and followed by a S or L, right? So this is how the string input string A and B would look like. So this would be, we would be given two such strings and those would be the size of two different t-shirts, right? And now we have been given some rules according to which we have to tell whether the first t-shirt is smaller than the second t-shirt, whether the first t-shirt is bigger than the second t-shirt, or they both are equal in size, right? So the rules are pretty simple. Let me just explain you. So if the first string has S and the second string has M or L, then the first t-shirt will always be smaller, right? If the first t-shirt size has L and the second t-shirt size has either S or M, it will always be bigger, right? And if we have medium, it would be bigger than the t-shirts having S, which is small, and it would be smaller than the t-shirts having L, which is large, right? Now the comparison that will be present there will be between the t-shirts which both have S and which both have L. So the rules for comparison is, the more X we have before S, the smaller it is, right? So if we compare these two t-shirts, then this one is smaller, right? And similarly, in a different way, when the number of X in front of L is greater, then it is bigger than the t-shirt with the less number of X's. So basically you can retain it as that this is extra small, and this is extra small, and this is extra large, and this is just extra large. So the more number of X before L, the greater it is. The more number of X before S, the smaller it is, right? So we'll just have to consider a few cases. This question is just casework. So if the given strings are equal, then both of the sizes would definitely be equal, right? Now if the first string and the second string both have the same character, right? If both have S or both have L, then we have to treat it as a single case, right? If they both have S, then the more number of X, the smaller it is. If they both have L, if the more number of X, the greater it is, right? And again, if for the remaining cases, if it is equal to, if the first letter is S and the second if the first letter is S, then it will always be smaller. If the first letter is L, then it will always be bigger. So this is what we have to do in the code. So let me just show you the code. This is the code I have written, in which I take two strings A and B as input, and if A and B both are equal, then I just print they are equal and I just return from the code itself, right? Now I create two characters C1 and C2. So I just store what is present at the end of A. So at the end of A, it would be either S, M or L, right? So it would be either three of those characters. I stored the end of A at C1 and I stored the end of B at C2. Now I compare both of them. If C1 and C2 are equal, then if it is equal to L, then I'll do it. If size of A is less than size of B, then it means it is smaller because the number of X present before it are less, right? Otherwise it would be bigger. And if the last character is small S, then if the number of characters or the number of X before S is less than, then the size would be greater. So this is exactly what we have discussed just before this. Now if the first character is S, then the second character would always be either M or L, then it would always be smaller, right? If this first character is M, then the second character can be S, so it would be bigger. If the first character is M, then the second character can be L, so it would be smaller. Otherwise, in any other case, if the first character is L, then it would always be bigger. So this particular question was just a bit of casework, and if you deal all the cases correctly, then you will get an accepted verdict. Now moving on to the second problem, which is funny permutation. Now this particular question says that we have to build a permutation of size n, right? So we would be given a number n in the input and we have to build a permutation of size n. Now the permutation should follow this particular case, that for each element pi, at least one of its neighbor has a value that differs from pi by 1. So either the element to the left of the element to the left of pi should be equal to pi plus 1 or pi minus 1, or the element to the right of pi should be equal to pi plus 1 or pi minus 1, right? So it should be like any of those cases. Either there should be it should be an adjacent element, right? So this is the condition. And the second condition is it should have no fixed points. Fixed point means that pi should not be equal to I. So this is one very important condition that we have to ensure, that pi should not be equal to I, and obviously it should be a permutation, so it should contain all the numbers from 1 to n only once, right? If no such permutation exists, then the answer can be -1. We have to print -1, otherwise we just have to print the permutation. So the important observation in this case is, in this particular question, is the answer does not exist for n is equals to 3. For all the other values of n, the answer will always exist. For example, let me show you. If I write 1, 2, 3, 4, 5. So for example, for n is equals to 5, what I can do is I can just initially write 4 and 5, and I can then write 1, 2, 3. Right? I can write all the remaining numbers. Right? So 4 and 5, they are. So let me just write the value of I as well. So this should be 3, this is 4, this is 5. So these are the values of I, and these are the values of pi, right? So they are not equal at any place. You can quickly observe that. And for 4, we have 5 as pi plus 1. For 5, we have 4 as pi minus 1. And for all the other remaining numbers, we will always have, like for 1 we have 2, for 2 we have 1 as well as 3, for 3 we have 2. So this condition will always be satisfied. Now let us check for any number, like let's say 10. So I can again write the greatest two numbers 9 and 10, and then I can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can easily just cross verify it or cross check it, that this will always satisfy the conditions, that we can just put the biggest two numbers in the front, and then we can just print the all the remaining numbers, right? But this would never work for like 3 numbers. Like if you try to put it like 2, 3, 1, then this will not satisfy the condition, because for 1 we don't have any neighbor, right? And for n is equals to 2, you can just deal it separately or write 2, 1, right? So this is exactly what I've done in the code. I just take the input n. If n is equals to 2, I just print 2, 1. If n is equals to 3, I just print -1. In any other case, I just print n minus 1 and n separately, and I run a loop from 1 to n minus 1 to less than n minus 1, and I just print all the values, right? So this is how I can solve this particular question. And moving on to the next question for today's contest, which is minimize the thickness. So it says that we have been given a sequence of n positive integers. So basically it's an array of n positive integers, and we denote a segment ALR. So this segment is basically a subarray from the whole array, right? So what we have to do is we have to divide the array into some segments such that each of the element is exactly in one segment. So right, so the segments should not overlap. Basically this condition wants to say that the segments should not overlap, and the second condition is that the sum of elements for all the segments are equal. So each of the segments should have equal sum. For example, like this is the given array, like this is the example they have taken. So they have taken example of this particular array, and the first segment can be the first two elements. So if we take the first two elements, the sum would be 100. If we take these elements 30, 30, 40, so again the sum would be 100, and then we take the last element, then the sum would be again 100. So we have divided into 3 subsegments. The first segment is this, the second segment is this, and the last segment is this. Each of the segments have equal sum, right? So now what we have to find is, the question has defined the thickness of the split as the length of the longest segment. So for example, in this particular case, this was the longest segment of length 3. So this is the thickness of that subsegment of this particular arrangement, right? So we have to find the minimum thickness that is possible over all the arrangements. So again, we have to find an arrangement such that all the subsegments have all the segments in that arrangement have equal sums, and the length of the longest segment in that particular arrangement should be minimized. So right, so this is the question. Now if we carefully observe, then the constraints are very small, and we can easily form an n square solution. So as soon as I think of n square, the first thing is I can just fix how many elements from the start I am trying to take, right? So if I take the first, for example, if I take the first element from here, then the sum is 55. If I have 55 here, then obviously I would try to make the sum of all the remaining segments equal to 55, right? So this is exactly what I have done. If I just take for the first two elements, then the sum is 100. Then I'll search for all segments for which the sum is 100 and whether such an arrangement is possible or not. And I will just brute force it through all the values and I'll find the minimum value of the longest segment, right? So let me just show you the code directly, you will understand it better. So what I have done is I created a vector v of size n and I've taken input in it. Now I just calculate the prefix sums for all the values in v. Now I initialize my answer as infinity to be a very large value. So I just initialize a variable first from 0 to less than n. So this first says that we are taking the first values, first I values. So basically we are taking first values. So if first is equal to 0, then we are taking one value. Okay, we are taking one value from the start, right? Again, if first is equal to 1, then we will be taking two values. If first is equal to 3, then we will be taking four values from the start, right? So I'm just taking the first value, one value. So this is basically I've done an indexing in such a way that it is from 0 to less than n, but it essentially means that I'm taking the first one value or the first second two values or the first three values, like like this. And for those first values, I have the required sum stored in pre of I, right? Pre of I is the prefix sum. So I've calculated my required sum. So this is the sum I would need for each of the segments of that array, right? Now I initialize my current sum and I initialize my last variable will store the ending of the last segment, the index at which the last segment ends. So essentially in this case it is the value of first, index first. Now I initialize OK is equals to true. Now OK will essentially store. So let me just write it in the comments. So this is the current sum, right? This is the index of the last segment. So this is essentially the ending index, right? So this is the ending index of the last segment, right? Now this will store whether this arrangement is possible or not, and I store nax is the length of longest segment in this arrangement. So these are the variables which I am taking, right? So now I just run a loop from first plus 1 because I've already taken first into consideration till less than n, I run into I plus plus. Now I increase my current sum with v of I. So I just add it to my current sum. If my current sum is greater than the required sum, so I have at some point sum of my segment has actually sum greater than the required sum, then I cannot form an arrangement with this particular sum. So I just set OK as false and I just break out of the loop. Now if I check whether my current sum is equal to the required sum. If this is true, then I'll reset my current sum as 0. I'll initialize my current size. So this is the size of the current segment, right? Now I just initialize it, current size, and I update the value of my last. So last would be equal to I, update the value of last. So last was essentially the ending index of the last segment, right? I just update the value of last, and now I update my value of maximum, which is maximum of nax comma current size, right? So this would be the size of the maximum segment, length of the maximum segment, right? So I update the value of nax. Now at the end of this loop, I just check if this arrangement was possible, if this is okay, and current sum is equal to 0. So I am checking current sum is equal to 0 because at the end I will reset the current sum, right? So it should be equal to 0. Now I just update my value of answer. Answer should be equal to minimum of answer comma nax. Nax is the longest segment in this particular arrangement, right? And at the end I just print the value of answer as my final answer. So this was the solution for the third question. Now moving on to the fourth question for today's contest. So this question is Masha and a beautiful tree. So this particular question says that there is a girl named Masha, which and we have a tree of containing m leaves. There are m number of leaves, and n is the number of edges. So basically, this is a complete tree, and 2 raised to the power equals to m. So this information is not very relevant, but we will focus on the question. Right. So this particular question says that this is a complete tree. So this particular information is important because this is a complete tree, which means that every complete binary tree, which means that every node will have two children except the leaf nodes. So it will always form a structure like this, right? So the number of leaves would always be a power of 2, right? So this is an important condition, and similarly m is the number of leaves in the given input. So we have been given an arrangement of numbers or a permutation of n integers as stored in the leaves. For example, the first leaf contains 3, the second leaf contains 1, the third leaf contains 4, the fourth leaf contains 2. So we have to tell whether there exists a way to sort all of these numbers in arranging order, in ascending order, right? And we have to tell the number of steps required in it. And obviously, if this is not possible, we just have to print -1. So how can we change this particular order? We have been given operations like it was mentioned somewhere around here, but let me just tell you in brief. So essentially what those operations say is that you can choose any node, right? If I choose this particular node, I can take both of its children and reverse them, right? So let me just show you with an example. I'll just take this. Right. So this is my example in the test case. So if I take 3 and 1, so if this has two children, 3 and 1, if I choose this particular node, I can reverse the order of its children. I can just invert it. So I have this node, and then on the left I'll have 1, and on the right I'll have 3, right? So this is what one operation can do. And if I chose the root node in this particular condition, so if, for example, if I choose the root node and then I take these children, right? So here it was 3, 1, 4 and 2. If I choose the root node, I can invert it. So this child will go to the left and this particular child will go to the right. So the new order would be, this is the root. On the left we have some node, on the right we have some node. Then on the left we'll have 4 and 2, and then on the right we'll have 3 node. So this is how the operations take place, right? So this is essentially the whole question. We can make some changes to the tree, and each operation is like taking a node and inverting its children, right? Inverting the tree, inverting the subtree essentially. So now we have to tell the number of operations required to make the whole leaves this particular order sorted, and if we cannot do it, we can just print -1. Observation 1. We cannot shuffle numbers. Shuffle numbers in the sense that we cannot actually mix the numbers. So if you see, then the numbers that when we choose a node and invert its children, then the numbers always move in a group, right? So for example, if I chose this node, then this will move in a group of 1 and 1, right? So this will essentially go here and this will essentially go here, right? But if I choose the root node, this particular node, then these two numbers will always move together and these two numbers will always move together, right? So it will never be like I can take 3 to this particular position with 4, or I can take 4 to this particular position with 1 or 3, right? So we know for a fact that we cannot shuffle the numbers and the numbers always move in a group. So as initially this group would be of size 1, then this group would be of size 2, then this group would be of size 3, and then size 4, and then 8, and so on. It will always be in powers of 2, right? So what we have to observe is that if we have some numbers, let me show you an example directly, how we'll sort this particular example. So if I have this example, right? So this is 6, 5, this is 7, 8, this is 4, 3, this is 1, 2, right? If I have this particular group, we have 4 groups initially, which is of size 2. So this is the smallest size. Now I check whether the individual elements inside this group is sorted or not, right? These are not sorted, so I can sort it, right? In this particular group, it is already sorted. In this particular group, I can sort it. In this particular group, it is already sorted, right? So I could just only change its internal positions. Now I take a bigger group of double the size, right? Now, is this sorted? Yes, it is sorted. 5, 6, 7, 8. Is this sorted? No, it is not sorted. Now I can sort it 1, 2, 3, 4. Now I take a bigger group. Is this particular group internally sorted? No, I can sort it by moving it to the front and moving it to the back, right? So initially the size of group was 2 and we have 2 individual elements in it, so we could change the position of these individual elements, right? Again, if we had this particular size, we could make a split exactly here and shift all of these 4 elements to this particular position and shift all of these 4 elements to this particular position. We cannot take any single element and move it out of the order. So this is what I meant when I said we cannot shuffle the elements, right? We cannot order it the way we want. We can move it in groups, and initially the groups would be like they would be individual elements which can replace or change position with its adjacent element. Then it would be groups of size 2, then 4 and 8 and so on, right? So how do we identify whether these elements are present in the group or not, right? So you will always observe that if I have to check whether this particular part has 2 elements that should be in the same group, how do I check this? The difference will always be 1. Again the difference would be 1. Again the difference would be 1. Again the difference would be 1, right, between all the elements. Now if I take a bigger group and I make a split here and I consider this as a single element and this is a single element, right, then again I will observe then the sum of these 2 elements and the sum of these 2 elements, if I take the difference between this, then the difference would be always 4. For example, if I take this example, 4 plus 3 is 7, 2 plus 1 is 3, the difference would be 4. Again, now in the next step the difference would be 16. What is the difference? 16. If I take a bigger group of this particular size and I divide it into 2 parts, then the sum of this particular part of all the elements in this part and the sum of all the elements in this part, if we take the difference, this would always be 16. So let me just actually calculate it. 5 plus 6 plus 7 plus 8 is 26, right? And 4 plus 3 plus 2 plus 1 is 10. So 26 minus 10 is actually 16, right? So at each step you can verify whether this sum and this sum, whether their difference is actually equal to this value or not. So how do we find this particular value? So if you carefully observe and just write down a few cases, you will observe that initially this value is 4, then 1, then 4, then 16, then it will change to 64 and then so on. So at each step this particular value is being multiplied by 4. Right. So as the size increases, you can just make this observation that it is being multiplied by 4, and we just have to check whether this difference is equal to this particular value or not. So in this way, we have found whether all the elements that should be present together are actually together or not. Right. So this is clear. Now the next step is whether to make an adjustment or not. So we need to make an adjustment only if the individual elements in that particular group are not present in order. Right. So for example, this particular element is not in order. This is opposite order. So what we have to do is we just have to swap it. How do we identify whether we have to swap it or not? So we can verify it as we have already calculated 2 sums, sum A and sum B. Right. So if sum A is actually greater than sum B, then we have to swap those 2 places and then we will increment +1 in our answer. Right. Similarly, if you observe in this case, the sum A was 26. This was sum A and this was sum B. So we actually had to swap these 2 positions. When sum A is less than sum B, then we don't have to make the swap. And if sum A is greater than sum B, then we have to make the swap and switch its positions. Right. So this way, the first step is to verify that whether this particular arrangement is possible or not at each step. Right. If this is possible, then it is fine. Now, if it is possible, then we have to find whether we have to make a swap to make them in ordered way or not. Right. If you have to make the necessary swap, we can make it or we cannot make it. Now there is one more important observation that is important to this question. That is, even if we make any number of swaps, for example, if at this stage I make any swap or at this stage I make any swap, the overall order, like if I consider the first four elements, the first four elements will always be the same, right? If I make a swap at this particular position, it doesn't affect my this particular position, right? Because 5, 6, 7 and 8 was present in the first four elements at this stage. 5, 6, 7 and 8 will always be present at this stage also, right? So if I take the first four elements, it would always be the same in this particular case, right? So for calculating sum A and sum B, I can use prefix sums and find the value of sum A and sum B over one time, right? So I don't have to worry about calculating the sums again and again. I can just use prefix sums and I calculate it over one time, because no matter how many adjustments I make at these positions, the first four elements will always be the same, right? Similarly, it goes for all the things. Like for example, if I consider till this position, the last four elements will always be the same. If I check at this particular position, I will have to check the first 8 elements, and the first 8 elements will always be the same, right? So this is how I actually check, how I confirm that my prefix sums would always work, right? So let me just show you the code now. So this is I just take an input n and I create a vector v of size n plus 1. Now I just run a loop and I just take input in it, and I calculate the prefix sums of size n plus 1. This is the vector, and p of 0 it will be equal to 0, and for all I can just calculate the value of p of I, right? Now I initialize the value of dx with 1. So this is the value with which I have to compare the difference of sums. Now I initialize my answer as 0 and I just run a loop from I to less than n. So at each step I'm multiplying I by 2. So I am just doing I left shift 1, right? So this is the size of the groups. This is the size of the individual elements I am checking, right? Now what I do is I just run a loop from j till less than n plus 1, and I just increment j by I multiplied by 2. So I'll just explain you quickly what I'm doing here. So initially, if I have 8 elements here, let this be the elements. Initially, I'm just taking size of 1, and I'll have a group of size 2, right? If I'm taking one element, I'll have a group of size 2. Then I'll move my pointer from here to here. Then I'll have a group of size 2. Then I'll move a pointer from here to here. So the value of I initially is 1, but I'm actually making a jump of 2, right? Similarly, if I is equals to 2, then these two would be considered as a single element, and I'll have to compare these two elements whether I have to swap it or not. Then from here I'll jump double the size of I, which is why I'm incrementing j by I left shift 1, which is essentially I multiplied by 2, right? Now I calculate sum A and sum B. So this is just basically I'm just calculating the prefix sums, and it is exactly as let me explain you this also. So j plus I minus 1 is essentially, for example, if I is equals to 2 and j is equals to 1, right? So j plus I minus 1 refers to this position, right? The next is j minus 1. So j minus 1 refers to this position. So this will give me the value of this in sum A. So this is sum A, right? In the next step, what I do is pre of j plus I multiplied by 2 minus 1. So I multiplied by 2 is 4. So I'm here currently j plus I multiplied by 2. I'll reach this position I plus 4, and I'll do minus 1. So my pointer is here now, minus pre of j plus I minus 1. So j is here plus I is here, minus 1 is here. So sum B is storing this, right? So this is essentially what I am storing in sum A and sum B. And what I can do is I can just check if the difference between them is not equal to dx, then I can just print minus 1 and return. Otherwise, and if this is equal to dx, I can just check if sum A is greater than sum B, then I have to increment my answer. and in the next step I just multiply dx by 4 every time. Right, now I just print my answer at the end. So this would be my solution for problem D. Now moving on to the last question for today's video, which is problem E. So this particular question is sending a sequence over the network. So this question says that we have been, this is actually a sequence A, and this particular sequence A can be split into segments such that each element belongs exactly to one segment. So this essentially means that there is no overlapping, right? Now the next condition is for each segment its length is written next to it, either to the left of it or to the right of it, right? For example, if this is a segment, then if it is divided into segments like this, so if I have one, the length of this segment is 1, so I take 1 and write 1 to the right of it or to the left of it anyway, right? Now I have 2 3 1, so this is 3, so I just write 3 to the left of this segment, right? So this is the actual segment and this is the length of the segment. Now I have 2 3, so I just take 2 3 and write the length of the segment to the right of it. So I can actually write to the left of it or to the right of it anyway, right? So this is how I can form my array B. So we have actually been given an array B in the question, and we have to find whether an array A exists for this array B or not, whether there exists an original sequence like this such that we can form an array B or not. So we have been given essentially this particular array B, and we have to find whether an array A exists for this or not. So for this particular question, we will just simplify the statement according to our needs, right? So for example, in the array B, if there is written 3 at some position and there are like 3 elements before it, alright. So this could have been some elements in my original array. So let there be some elements here also, P, Q and R, right. So this were some elements in my original array A. So this could have been some elements in my original array A, right. So if 3 is written here, there might be some, so this 3 might, let me just write it somewhere else. This let us just consider this as another example, right? So if we have 3, if 3 is written here and we have 3 elements here, so this is possible, right? And this is also possible because this is the size, this is segment of size 3 and 3 is written after it. Again, this is also possible, right? That this is a segment of size 3 and 3 is written before it. So if I consider that this is the value added in the segment B, these are the original 3 values in A and this is the value added later on. So I can say that from this position I can jump to this position, right? Because for these elements this belongs to a single entity in array A, right? A single segment in array A. Similarly, if I consider that this 3 has 3 elements before it, then from this particular position I can jump to this position because this would be considered as a single entity in array A, right? So this is exactly what I have to do in my question. For every value I can essentially form the jumps, right? For each position I can form, like from here I can jump here or from here I can jump here, right? For each value there will be 2 such jumps, right? And if I have my array B something like this and I have created my jumps something like this, right? So there are some jumps. So if you observe it carefully, then this is actually being converted into a directed graph, right? So these are the nodes and this is a directed graph. So this is node position 1, 2, 3, 4, 5, 6. So this is the nth position of the array B and this is the n plus 1th position of array B. So if I can reach from this position to this position, then obviously we can form an array A from the given array B, right? So what we have done is we have essentially reduced our statement into, or the given input into, a directed graph, and we just have to find whether this position n plus 1 is reachable from position 1 or not, right? So this is what we have to find in our question. So let me explain this particular part again, that for every element we know that if we consider that these 3 elements were a part of the segment and this is the length, then I can consider this as a single entity and I can jump from here to here. And if I consider this as a length of the segment and these are the actually the part of the subsegment or the segment, then I can consider this particular whole entity into a single entity of array A, initial array A, then I can jump from here to here. So after I form my graph, I can just check from position 1 whether I can visit position n plus 1 or not. So this is exactly what I have done in my code. I just take an input n and I just initialize a vector of size n plus 1 and I take input n. Now I create a graph of size n plus 2 because I have to check whether I can reach n plus 1th position or not, right, or n plus 1th node or not, right. So for each value in the input array V, I just calculate two values L and R. So L is calculated as I minus V of I. So if L is greater than 0, I just insert at G of L, I insert I plus 1. So what I am doing is, if this value is 3 and it is at index I minus 3 would correspond to this particular position, or it would correspond to this particular position, right. Now from here I can jump here. So this should actually be this position, right. I cannot jump from here. This should actually be this particular position. This, right. From here I can jump directly here, right. So this is possible. So that is why from at G of I, I insert I plus 1. And then I calculate R is equals to I plus V of I plus 1. So for example, this is I, and V of I plus V of I would be this particular position, and plus 1 would be this particular position. So from here I can directly jump here. So this is why if R is less than n plus 2, I just insert G of I dot insert. That means I just create an edge from here to here, G of I dot insert R, right. Now I just simply create a Boolean vector of size n plus 2 and all initialize with 0. I just create a function DFS starting from node 1 visited. I just pass the visited array and the graph itself, and this is a simple DFS function. I just check if the node is visited, I mark it as visited. I just mark the current node as visited, and for all the children of a current node, I just check if it is not visited, I just call the DFS function again. So this is the simple question, and like here I can just check whether the n plus 1th node is visited or not. If it is visited, then the answer would be yes, otherwise the answer would be no. So this was like this is the straightforward DFS implementation, and at the end I just check whether the n plus 1th node is visited or not. So this was it for today's video. I hope you guys were able to understand the solution. So till the next video drops, keep coding, stay safe, bye bye.